Welcome back, everyone, to Coffee with Keiko. I am your co-host, Kyla. This is my co-host, Paige, and this is a podcast where we have our morning coffee. My stuffed animal, Keiko, and Paige asks me questions about marine mammals, and I am a naturalist in the Pacific Northwest, so that is the biology, that's the ecology, that's the wildlife I'm around on a daily basis. But we really try to keep this global reach and talk about any kind of species that come to mind. So let's go ahead and get started. How are you doing, Paige? What do you wanna talk about today?
Well, I'm doing good. I went on a hike in the desert the other day and sort of got lost. I found my way back, but do whales get lost? I ended up having to pull up my phone and I did have service, so I was able to figure out which direction I needed to walk when I eventually made it to the road. Um, in the desert, it's a pretty scary place to get lost. But I figured it out and we're safe and we're just not going to go that way again. We'll go on the other way. But how do whales do this? They can't go pull up their phone and go, I need to go that way to the parking lot.
Yeah, desert doesn't have very many road signs or
No,
features.
it's just cactus after cactus after cactus. And it was mostly because I was going on a trail that was supposed to go along the creek. The creek was dry. And so then the path and the creek just kind of like merged. And then so I ended up in the creek, but I was supposed to cross. I didn't know where the path picked up again. So then I just like stayed in the creek because it was just cactuses.
I'm really glad you had GPS. That could have
Yeah.
ended badly.
I knew if I kept walking, I would hit the road. And then I just had to know if I turned right or left once I got to the road. But I figured it out. It was okay. There was not even a single tear shed because I knew I wouldn't probably die. Don't tell my mom. She doesn't like it when I hike in the desert alone. She's like, don't get lost in the desert. I said, I won't. And I got found again.
Would have been helpful if you didn't have your phone.
A compass?
Yeah, magnetism.
Magnetism. Do whales have magnetism sensors?
That is the segue. Yeah. They sense the magnetic lines of Earth. So if you are asking how they navigate and how they don't get lost, they do get lost sometimes. We'll get to that. But how they actually figure out which way to go, it's mainly because of the magnetism of the Earth. So a little astronomy background. The Earth is spinning, and the Earth has essentially semi-liquid stuff in the core. So the spinning of the Earth with the spinning of the liquid causes this magnetism. So we have the North Pole and the South Pole. So that's how compasses work, is it points towards the magnetic north. But the direction the compass points towards the magnetic north is not necessarily actually always true north. It's not actually the geographic North Pole all the time. And so we have these magnetic lines that NOAA and other scientists can draw essentially fake magnetic lines across the Earth that kind of show what level of difference that is from magnetic north to geographic north. And migratory animals can sense these lines and use that for direction, which is so cool. So scientists have long known that this has played an important role, but we really don't know exactly how they do it. And so there has been different studies on different migratory animals on how they might be using different features to figure out navigation. So it seems like with birds, they might be able to actually see these magnetic lines, which is pretty crazy. With whales, we don't know if they're seeing them or if they just know them. We don't really know what the sensory perception in their brain is, but they're definitely using these lines. There's this one study that came out in 2024 that showed that not only do they use the magnetic lines, but they also use the direction of the rising sun. And so it's kind of the analogy I like to use is if the magnetic lines are like the road that you're following, the sun acts as that signpost to let them know where along the road they are. So this research took 240 years of whaling era data, as well as a bunch of data from tracked whales on essentially where these whales are found in their migratory corridor. And a different study found that from year to year to year to year, that like migratory pathway will stay consistent to the 1th degree. They know their course and they're sticking to it. And it's just like, that's still just kind of crazy because this is in the open ocean. This is going from Alaska to Hawaii, for example. They're finding this tiny island in this vast basin. Sometimes they'll go down like the coast from Alaska to Mexico, but if they're going to Hawaii, they're going across the ocean. So there's not landmarks for them to keep track of, kind of like being in the desert.
Yeah.
So scientists have found that one, they stay along these magnetic lines. And it's kind of similar in looks to a topographic map. So if if you're in a valley and everything is kind of the same elevation, the lines are really spread apart. They're kind of at the same elevation for long periods of time. And those spread apart magnetic lines that aren't really changing very much, those are the lines that the whales like. They don't like the lines that are close together because basically if they make any kind of mistake, suddenly that signal to them is telling them they're in a different spot than they are. It's a lot more drastic of a magnetic change, like we would see if we're walking up a mountain, a lot more drastic of an elevation change. So they like these areas of low gradient magnetism. They also, like I said, use the sun. So they're looking at like the angle of the sun to the magnetic line they're following. And that essentially lets them know not only what part of the world they're in, because the exact position of the rising sun will change depending on what part of the world you're in. It also lets them know the season. Because since the Earth's tilt with the seasons, whether the pole is pointing towards the sun or away from the sun, the exact point of the rising sun is going to change. So how this is in practice is like these humpbacks, they're born in Hawaii, they migrate to Alaska, and the moms teach the calf where to go. And they're essentially taught, like, not just follow this road, this magnetic line, or not just leave when the sun looks like this on the horizon. It's essentially follow this geometric intersection of this sun at the angle to this line, and that's how you know you're at the right place at the right time.
That's very cool. And it has more variables, you know. The magnetic lines are probably not shifting that much, but the sun and the seasons, it's a very ever-changing variable.
It's mainly magnetism. If the sun is signposts and seasonality, they do use their other senses too. It's not like they're locked into these two things. Like whales and migratory animals are incredibly intelligent and they can be quite adaptable. And when researchers, they're trying to figure out complex things like this that aren't fully understood, to be able to say it's this, they kind of have to rule out all the other variables, right? So they've also looked at things like I said, whales can smell. Are they using sense of smell? They're looking at things like, are they using the currents? Are they using like the temperature? Are they using their eyesight and kind of seeing where landmarks are all around them? And they're probably using a little bit of all of this because they are kind of like, they've got their road, they've got their signposts, but they're paying attention to the seasonal markers around them as well. But they're not using that as their guiding compass, so to speak, because there are a lot of environmental fluctuations that are very natural, like El Nino and La Nina in the Pacific Basin, that will change the exact temperature of the water at an exact point. So the whale can't rely on that to let them know where they're going. But they have been shown to take that into account on when they're going to time their migration. So when they actually leave on their migration, sometimes has to do is inputted by where the rising sun is. It also has to do with the conditions they're feeling at that place because they have the forethought to be like, okay, if I am in my breeding grounds in South America right now, and these are the conditions I'm feeling here, then that means that's what the conditions are going to be in Antarctica by the time I get there in a month. And so they are able to actually adapt a little bit, which is great, which we talked about with climate change. Being able to change the timing of migration is super helpful. But they also use sound. So specifically listening to each other. So they're kind of timing that migration together. And it's also like nice because when you're traveling with a buddy, if you accidentally miss the path and they don't, they can be like, hey, over here, this is the way we need to go.
Yes.
And as you have experienced hiking alone, a
Yep.
buddy would have been
You
helpful.
should always hike in the desert with somebody. Have a buddy. The birds don't count, no matter how cool your binoculars are. They're not very helpful. They were just like, haha, you're being eaten by mosquitoes. Hmm, maybe I'll eat the mosquitoes for you. Not.
But yes, so the whales, they are using each other as help. They're not doing this by themselves, which
It's the buddy system.
they have a very good buddy system. They have a long distance buddy system. So the researchers, the specific study I'm thinking about,
But long distance relationships never work, Kyla.
not if you're a whale.
Oh, okay. That solves it. Okay. I'll keep that in mind.
We talked about this in like one of the last episodes. It's like be a whale, be more like the whales. They're economists. They're also very good at long distance relationships.
Okay, got it.
They're also not monogamous or patriarchal.
We're pretty good. Look at our long distance friendship.
Yeah, we're pretty good. We're pretty good.
We are like the whales.
Yes. So blue whales, they found that when the blue whale, the individual blue whale, participates in talking to its fellow blue whales, because like humans, whales have different personalities, and there are some antisocial individuals out there who participate in vocalizing less, and they don't do as well. The ones that are vocalizing and kind of talking to each other, essentially they're helping each other with their migration timing. They're also kind of helping each other with like, hey, there's a lot of food over here. So the ones that are talking have better migration timing and have better foraging success. And you have to kind of be careful on the internet when you look up whale vocalizations and like their distance, because I was trying to find a study that showed how far their vocalizations can travel. And unfortunately, a lot of the scientific papers that had any kind of data like this were blocked by paywalls, which now that I am not in school, unless I had saved the PDF, I don't have access to. And so I found the study that was talking about how they put a hydrophone in the water and they calculated how far away their hydrophone could hear the humpback whales, which is a good proxy for how far they can hear each other. And it's depending on the pitch of the call, it's between 27 to 155 miles away. So for context, Seattle to Mount St. Helens is 150 miles away. So that'd be all like, I'm shouting in Seattle and my buddy in Mount St. Helens can tell me what he sees down there and if it's good conditions and if I should go join or if we need to leave for migration routes so we're not late. Or so it's hugely beneficial. But I say be careful about this because there are websites that talk about how far they migrate. So they might migrate 6,000 kilometers one way, or sometimes that gets translated to a different website as 6,000 miles one way. And then you go to a different website and it says they can communicate from 6,000 kilometers away. And then you go to a different website, it's like they can talk from 6,000 miles away. And if you see something on the internet that says the humpbacks are communicating from 6,000 kilometers or miles away, that is wrong. From New York to LA is 4,000 miles.
More evidence that we cannot handle the metric system. And B, don't trust things on the internet.
Yeah, no, I don't. It was kind of entertaining for me to see the direct, like, because I was looking at all these different websites to see if I could find any sources that show how far they can communicate. Because I'm like, I know it's not 6,000 miles. Yeah, so that's how they navigate magnetism, the sun, and the buddy system.
So they can accidentally get off on the wrong kind of magnetic line. What are some other things that can lead to a lost whale?
Really, it kind of comes back to those magnetism, or comes back to those magnetic lines. Have you ever heard of a solar flare?
Yes.
The sun has essentially, we call them mini explosions because on the sun's surface it looks mini, but these are massive massive explosions are happening on the surface of the sun all the time. And you hear about the solar cycle and these things called sunspots. And sunspots are when you have these arches of magnetism that are so strong, it's stopping the heat where those arches are connecting. So it's kind of like if you think of a rainbow, but of magnetism on the sun, and the ends of that magnetic rainbow, so strong magnetism blocking the heat at that one point. So when you're looking at
it's a rainbow of magnetism with no gold, but coldness.
Yes.
Okay.
And that's because like the sun is a gas, and it's also spinning. And so it has such intense magnetism that we can't even comprehend happening from all that spinning and activity. And these magnetic arches will break. They'll twist and flex, and eventually they'll just break. And that is it's explosive magnetic energy that essentially pours out atoms at Earth. And Earth's own magnetic field, as it's spinning, protects us from this kind of constant onslaught of material that the sun is chucking at our atmosphere. But where our magnetism is also condensed, the magnetic particles coming from the sun interact with our atmosphere, and that's where we get the northern and the southern lights. And so when there's a solar flare, what we call it, where we have an extra amount of that material being chucked at Earth, that's when we can see the northern lights at, farther south than normal. You get news like, oh, you can see it in Washington today. Or the really intense ones are when you can see the northern lights in Mexico. Mm-hmm. That's crazy. And if you can see the northern lights in Mexico, the whales are not having a good time.
No.
Because the magnetic chucking of material from the sun at Earth can essentially change the magnetic signals that the whales are sensing. And so suddenly they think south is north or east is west, or they're in the Atlantic when on the East Coast when they want to be in the Atlantic on the West Coast, and just completely disorient where they're at. So there has been a lot of studies across different whale species showing that solar flares are correlated with whale strandings, where they think they're in the middle of the ocean and they accidentally end up on a beach. Visually, if it's at night, they might not be able to see the shoreline. And so they're really using that magnetism for that sense of direction. And so it can be extremely confusing.
Solar flares, like their roads are under construction and they take these detours and they get lost because it said can't go that way, detour this way, and then the sign's broken and all of a sudden you're on a beach.
Or like if you've ever tried living in Seattle and driving in Seattle, it's like, okay, I want to get onto the freeway and go north, but then you have to go south to go north, but then you accidentally get on the wrong road going west, so it loops you back east, and then you're going south again, and you're just like, I just wanted to go on I-5.
Yeah.
The massive spaghetti bowl of magnetic lines. Yeah. And we see this more often in like temperate regions. So a lot of studies have been specifically focused on sperm whales with this, because female sperm whales stay more near tropical waters, while the males will kind of explore more into the polar regions. And so the lone bulls are more likely to strand during a solar flare because there's just more intensity in the changing in magnetic lines in the polar waters, which is also crazy to think about.
Also, you're thinking they also get closer together.
Yeah.
So
that topographic gradient of magnetic lines.
That wiggles is gonna wiggle closer together.
Yes. And I mean, like, whales will strand for other reasons. If there's a stranded whale, it doesn't necessarily mean it was because of a solar flare. Whales will, unfortunately, human impacts like our seismic array testing, any kind of like Navy sonar testing, or ocean floor exploration for the oil industry, causes a huge amount of sounds. And since their melons, like especially the toothed whales, their entire brain is set up to concentrate small amounts of sounds. So when you have high intensity, high pitched sounds, it can literally just cause brain hemorrhaging, where their brains just start bleeding and they die. So any kind of intense sound production can lead to beaching, because they are in so much pain, they're confused, they don't know where they're going, they land on a beach. Any kind of, like, sometimes sick animals get disoriented, beach themselves. sometimes they're just not paying attention to the tide. Like that actually has happened a few times with the killer whales here in the Pacific Northwest, where they will go in with the tide to get like super close to sill haul outs because they want to eat those sills. And if they're not paying attention, they can get stuck up on tidal flats. So we have one whale named Sydney, and she was pregnant with her third calf, who's named Lucky, because she and her son Stanley got stuck up on a tidal flat. And being beached is incredibly dangerous for the whales. A lot of them will die. She luckily did not die. Her and her son were able to swim freely away, and she gave birth to a healthy daughter named Lucky, who's still alive and is named Lucky for that. But then also 2 years ago, we had a female who she kind of did the same thing. She was just kind of like on this rocky outcrop that was, I think, higher above the water line than she thought. And so she got stuck up on it during low tide. But she got stuck up on it on her side, which is more dangerous because when the water came in, essentially it covered her blowhole before she had enough water around her to straighten herself. So it drowned her, which was really sad. It's still kind of a big deal here. Yeah. So there are other reasons they can strand, but a lot of mass strandings are correlated with the solar flares. And what's also interesting with that, I don't know if you've heard this, the North Pole is not always the North Pole.
What do you mean by that?
The magnetic North Pole and the magnetic South Pole, they flip.
Oh, yes. I think I heard that. Yeah.
So it's like every 20,000 years, they flip. Be confusing. I thought it would be like this big catastrophic event. It's like, how do we even have whales or migratory animals? And then I looked into it, and it takes a couple thousand years to flip. So it's not just like one day.
Yeah.
Everything's opposite. It's like it does take time to flip. So the migratory animals do adapt with that change over that multi-generational time frame. But
yeah. They can adapt to that 1,000-year change.
So like one of the next questions that comes up for me is like, okay, so they sense magnetism. Great. But how? And why can't we? We don't really know how. Like I said, we just kind of have the data that shows that it's what they're using. We have magnetite in our brains. It's just like a magnetic material that might be contributing to it, which humans also have in our brains. It does seem like the entire cetacean lineage, both toothed whales and baleen whales, have the ability to sense magnetism. So maybe it's more the product of being a land animal. That's a flying animal or a water animal, in that there's just like less land-based markers to use. Because like bottlenose dolphins, they're not necessarily known for migrating across ocean basins like humpback whales or baleen whales are, but they can definitely still sense the magnetism. And there was like a study that proved this by having two objects of the same density, same shape, same everything, so that the dolphins couldn't distinguish the two of them separately from echolocation. But one was magnetized and one was not. And these trained dolphins found the magnetized object faster every single time. So it's like they have some kind of magnetoreceptive behaviors, even if they're not doing long distance migrations, which is cool.
Yeah, it's very interesting. Yeah.
I don't think I told you about the sea turtle magnetic studies. I gotta tell you this. Back when these different groups of researchers were trying to essentially prove what marine mammals or marine animals are using for navigation, sea turtles have sight fidelity. Right? They go back and lay their eggs in the same beaches that they were born, which is why conservation for sea turtle nesting beaches is so important, because humans really like beaches too. We like to build on beaches, but they go back to the same beach they're born. So we really need to preserve these breeding sites for these sea turtles so they don't go extinct from us taking their breeding space. And so because they have that insane sight fidelity, obviously they have good navigation tools to be able to go an ocean away and then come back to breed. So there was two different studies I read that kind of did two iterations of the same thing, where they caught some wild sea turtles and tagged them and then put them somewhere else. So they're just like, okay, this is not on your migratory route. We're gonna put you in some random place in the ocean and see if you can still find your way back home, even though it's not on your migratory route. And they did. All of them in the study, except for one sea turtle, found its way back home. And then in this follow-up study, they did the exact same thing. But on half the sea turtles, they taped a magnet on top of their head. And the sea turtles that had magnets on top of their heads, they still found their way back home. But it took them much longer. And that was like the scientists saying, like, see, they must be using magnetism because when they have magnets on their head, it takes them longer to get back home. I was just like, those poor sea turtles just got alien abducted out of their ocean and glued a hat on their head and then placed somewhere random as they're trying to go home to breed.
Probably they got made fun of for having a dumb hat on too.
I know. I mean, like, how much of their time of being late was them trying to get the hat off their head? Well, do you have any other questions for me?
I think we covered how they navigate and how they get lost. We can take on some of that information of using the buddy system, taking a compass when you go out to the wilderness, and always having extra water, a way to filter water. That's a good outdoor tip. But I feel like we've learned a lot. Do you have on your website many photos of whale buddies, of groups of buddies? Some buddy systeming whales?
I do. Yes. On my website, Kyla's Naturalist Photos, there's a lot. There's a lot of orcas and humpbacks, and there's even a gray whale one. So, yeah.
That's good. Thank you for educating me on this lovely podcast of Coffee with Keiko. Is it Keiko or Keiko?
I've always said Keiko.
Keiko. Keiko.
I don't think it's Keiko. There's another whale here, or there's a place. I've always said Tahlequah, because that's what I thought it was spelled like, but then I've heard other people say Tahlequah, but I still say Tahlequah because I always see these things from reading them, and I don't necessarily think to look up how to pronounce these things before talking about them, and then people are like, you're saying it wrong. Okay. Or like, do you remember in high school how for the longest time I said Southern?
I do not remember.
Okay.
You're saying Southern.
I'm pretty sure. I know my family made fun of me. And I was just like, well, it's Northern. It should be Southern. And they're like, it might be what it should be, but it's not. It's Southern.
Yeah. Nope. Yeah. I very confidently answered a question for the eustachian tube. I said escutcheon tube because escuchar means to listen. So you should say it like escuchar. It's a tube in the ear. It's eustachian tube. Escutcheon tube makes way more sense. Sounds stupid. Well, thank you for joining us with Coffee at Keiko. If you want to learn more about marine mammals, you can go ahead and follow our previous podcast, like and subscribe, and ring the bell to get notifications of our next podcast releasing in 2 weeks. And always go on kaznaturalistphotos.com and do some shopping for prints, mugs, keychains. Make great gifts for yourself or others. And join us in 2 weeks. I don't know what we're talking about, but I'm sure it'll be fun.
I don't know what we're talking about either. We'll figure it out. And if you want behind the scenes, we have, I have a Buy Me a Coffee page, which is like an alternative to Patreon. And we have a Coffee Pod subscription. So you get these a little bit earlier and also behind the scenes, where today's behind the scenes is as soon as we end here, I'm going to be talking Paige's ear off about all of the lost whale stories, because there's a lot of like, this little individual lost whale was 3,000 miles away from where it should be. So behind the scenes, it's got some great stuff. It's got extra fun facts. Check it out. It's only $5 a month. And you're supporting
a bargain.
The hours of work I do to edit these videos.
Yeah. To educate the public.
To edit the videos to educate the public. Yes. Thank you. Bye.
Bye.